Throughout this presentation, we will discuss the purpose of the Lokomat exoskeleton, how the exoskeleton device works, the type of patients who can benefit from the use of the device, current advantages and disadvantages, possible improvements that can be made, and the price and availability of the product. The Lokomat is the single most popular gait rehabilitation device since 2016. It is a modular, fixed gait rehabilitation exoskeleton. The Lokomat system suspends the patient using an overhead harness. All of the gait training takes place over a treadmill. Although the patient has lost the ability to walk, the Lokomat provides modifiable features such as harness suspension, adjustable robotic gait orthosis, and augmented performance feedback. What the Lokomat loses in being a fixed device is that it cannot leave the room. The purpose of the Lokomat exoskeleton is to improve the patient's strength, motor planning, coordination, and sequencing during walking. It is a robotic device designed to allow intensive rehabilitative gait therapy in adults and pediatric patients with severe to moderate walking impairments. The Lokomat primarily helps patients who have sustained a spinal cord injury, brain injury, stroke, or those who have been diagnosed with multiple sclerosis, cerebral palsy, Parkinson's, and more. The Lokomat focuses on retraining the patient's motor function and neuropsychological mechanisms. The Lokomat exoskeleton works through several different features. The first one is an electronically powered, computer-controlled lower limb exoskeleton, which actively guides the patient's leg movements while walking on a treadmill. It also has an integrated dynamic body weight support system, allowing constant unloading of the patient's body weight throughout the gait cycle, and also enables upright posture. Another feature is real-time biofeedback, which can provide encouragement and challenges the patient throughout gait training. Some more features that are provided so the exoskeleton can work properly is attaching the exoskeleton robotic legs to the patient's legs, which allows the therapist to control how fast the patient walks, how much body weight the patient can support, and how much help the robotic legs gives the patient to move their legs as they walk. Controlling the repetitive walking pattern helps the brain and spinal cord work together to reroute signals that were interrupted by an injury or an illness. If you're wanting to see in more detail exactly how the Lokomat exoskeleton works, feel free to watch the video below. A few important advantages of the Lokomat exoskeleton is that it helps rehabilitate patients quicker and in a much easier way, increases function and reduces sedentary lifestyle, improves patient motivation and positive feedback with validation, helps with pressure relief for those unable to ambulate, and it also increases circulation. The first advantage of the exoskeleton is a quicker rehab. Utilizing the exoskeleton during gait rehabilitation will allow the patient to return to ambulating much faster, easier, and in a safe manner. However, without the exoskeleton, the patient would have a slower improvement in ambulation due to the lengthy strength gain process. Once the patient begins gaining strength, they may still only be able to ambulate for a short period of time or distance, as opposed to if they were able to use the exoskeleton. By utilizing the exoskeleton in the early phase of gait rehabilitation, patients will be successful in regaining function and mobility sooner with the use of the device versus without it. For example, the dynamic body weight support system provides the patient comfort as they can ambulate without as much of a weight barrier. This can be especially helpful for the patients who live a sedentary lifestyle.
The next advantage we'll talk about is patient motivation. When using the Lokomat, patients are able to ambulate earlier than without, which is great motivation for them to want to get up and start moving. By giving them this opportunity, it initiates positive feedback and validation. Another advantage to the Lokomat is pressure relief. Sitting for an increased amount of time greatly increases your chance of developing pressure ulcers, and with the Lokomat, we can stand the patient who generally would not ambulate or stand to eliminate the pressure on the patient's ischial tuberosity, sacrum, and much more. Another great advantage to the Lokomat is that we can increase circulation. By getting the patient up and letting them ambulate in the Lokomat, we increase the circulation and tissue nutrition, which can have positive effects in all internal organs and functions by ambulating. In the next 3 slides, we will discuss the disadvantages of the Lokomat. While the Lokomat has many great advantages, there are a couple of disadvantages. One is that it is expensive, the second is that it is bulky, and the third is that it is not made for in-home use. Lokomats can cost anywhere from around $300,000. That is extremely expensive for any therapy program and limits the amount of facilities to have them in their gyms. The second disadvantage we have listed for the Lokomat is that it is bulky. These machines can be very cumbersome and bulky, making it hard to load the patient in the machine. It is also hard to move the machine itself, and it's also hard to find space in your gym to put it. The last disadvantage we have listed for the Lokomat is that it is not suitable for in-home use. Because of the cost and the size and the expertise needed to use the Lokomat, it is currently unavailable to the patient in the home setting.
We consider different ways to improve the device, mainly by reducing its size and weight in order to make it more accessible, by adding VR technologies and sensors to make it more accurate, and by reworking the harness system to make it more comfortable for the patient. The primary improvement will be to find a way to reduce its size and weight. We could first use motors with improved performance in order to reduce the size of electronic components, and then we could use other materials such as aluminum, carbon fiber or composite materials that have better specification in terms of weight resistance ratio. We will also add virtual reality technologies such as headsets and position sensors, which will allow us to create simulations in order to meet specific patients' needs. Combined with the exoskeleton, we will be able to provide the patient a better experience and achieve better results in a shorter period. Lastly, the final improvement will be to rework the harness system, which seems to be uncomfortable and very restrictive for the patient. By finding a way to make it more stiff and more permissive, and in combination with the other improvements, we will be in the capacity to offer the patient a better immersion in the rehabilitation process and to make it more efficient.